ladies and gentlemen, Mace is here and live, and today we are going to build a Matlab model and at least start the basics of the Matlab Simulink model so that we can basically later on control the burner later on with it, and we can make PID and all that kind of fun stuff. But first we'll have to launch the Simulink, and then we will have to put the model together. Honestly, this is the first time that I do a Simulink model by myself, so I will use ChatGPT to initialize and to basically learn as much as possible, then extract the knowledge into this video, or maybe just record it and then extract it later. When I recap it, I will make and I am making artifacts. Just I'm not really progressing with them. These artifacts contain the data and learning that I do here, and basically the experience, and yeah, I will basically collect every thing and every correlation that I can find into those artifacts, and then later on publish them with bigger videos that are going to be full detailed on, like airflow mapping, and then maybe mopping as well, then the pump burner, whatever, so pump, the air screw, the blower, all these mapping, then system control, the burner itself, how it is built, and why all these. So yeah, we will create a blank model, and for a good start, as I usually do, I will go and grab myself a coffee and make myself a coffee, and then we'll come here. Oh, we can actually I think this was it. So yeah, just wanna yes. Though this music is good, yeah, this is pretty good. Unfortunately, I cannot untitled. So first I will grab a coffee and then figure out what to do. I'll save this first. I don't know. Let's go to the burner. Let's go with this single one or model one, maybe. That should have been better. Whatever. I'm going to go and grab myself a coffee, and then return. I will come back stronger. Great. Maybe I'll close the door. So, where were we? First 10 minutes AFK, great. Ah! Stop the fucking thing. I'll measure temp, nor the nor the pressure, nor also burner Great. Didn't I get the fucking blower mapping on the PC? Or onto the pen drive? Come on. This is it. Oh, this is just the code. Test2. What is this? Oh, yeah. Nothing good. No, this is not it. Nope. Nope. Great. CAD. Boot. I suppose I have not fucking did. Need to extract the fucking files. I will fucking take these shitty files once and for all. Fuck. Extract them from the other PC. Just need to turn it on and so on. Not a fast process. Az rock. Let us do something. We can go with this. Is this a fucking joke again? Why? I really hope it doesn't shut down. Basically, the PC wants to set itself to Windows 11. Great, very well. Good job. What a garbage shit. No, fuck you. If you do this again, I will turn you off. I don't know. I can't do much more. Come on, please. Please work. Don't put the Windows 11 on. Not again. Like, is this a fucking joke? But who the fuck? Alt, Control, delete. Windows Control Shift. What was it? Alt, Control Shift, delete. Very well. What a lovely fucking surprise for the day. Great. Love it. Will you shut down? So much so for the fucking effort. Remove the fucking pen drives and idiot fucking retard bitch PC. Fuck you. Nothing wants to work, for fuck's sake. No, fuck you. Alright, fuck this whole thing. Then we will find this garbage somewhere. I have like 100 fucking. I think it was in this. It just takes forever to fucking load this shit in. I don't know why this does this. I honestly don't understand. Yes, Sigma. Did I put the fucking filter pmed? Yes. Oh, I have the Matlab code. Fuck you then. Hooray. Oh yeah, let's go. We don't need this garbage. Oh, let's go. It's here. Yeah, fuck the whole thing. Q, PWM. You have to. We need to make another fucking. Maybe I will need to delete the old projects or some shit. Maybe. Did like this that like like see, it always freezes up. Ridiculous. Alright, let's see what up. From your feet. Yeah. Yeah, we'll do this today, hopefully. Why is this so loud? Yes. Let's do developer. Startup sequence, purge, ignition, ramp. Good triples, fuel blower, atom. Actuator maps. Placeholder. Yeah, I will need to do this now, because I have done this before, but it will not be good because even if I got the data, which I do have, I don't know in which chat, but I do have it. The problem is that the overhead, basically, I don't know, I don't have anything on this PC because the other PC has all this. We need to fucking buy a new hard drive so that we can put the Windows on that bitch. So fucking annoying. It's the same thing, whatever. So the point is that we have the pump, let's say, have the pump, have the fuel tank here with the little legs, and we connect the fuel line, let's say with blue. We connect the fuel line to the pump. From the pump I use the line, and basically I have led the line into a tank, which was a jar, or not jar, a 1 liter PT, not PTFE, HDP, so high density polyethylene tank made for like chemicals. I have pumped the fuel into that and put a scale under it so that to measure out the weight per given amount of time. The problem is that this is basically set for this height difference between the pump and the should have used the fucking straight lines. So basically this, but because now it will be changed to the same level here, and because this is like a what do you call it, a windshield wiper motor or pump, it is basically so to speak very weak pump, and it is dependent on, or no, it's from here, is dependent on pressure very highly, overhead, that is basically after, like between this and the level that you want to pump the fuel to. So basically as you increase the fuel, the overhead, then it might not decrease in pressure linearly, but maybe exponentially. So this is this is pressure, and this is going to be the mass. So the lower the pressure, the higher the mass, and the higher the pressure, the lower the mass. Exact same thing here. We do not know if it is linear or exponential, because if it is exponential, then it's not the same data, because you cannot like take a number and say that, yeah, this is 260 mil, and now it will be maybe 20 mil high difference. Then we proportionally like interpret the data. That will not work, or might not work. So we'll need to make another measurement, which is basically on the new height which the fuel pump is going to pump the fuel into the actual what do you call it, actual oil gun itself. So yeah. So we have some data, don't have to find it later. So come back to here, go back down. What do we have here? Yeah. So yeah, PWM fuel is need to be remeasured so that we can derive. Basically, I have made the paint again. So I have made the function in terms of PWM. So the function depends on PWM, or it is a function of PWM, to be honest, and it is a function of overhead, which we are going to just use H for. But this is not yet derived, so this needs to be measured with multiple heights. And basically we need to measure multiple heights, and we need to do the PWM testing on both, like all of them. Then we can derive we can adjust the function according to that. We will get like functions kind of like this. Let's go with black. So this is going to be m dot, this is going to be p, and we are going to get something along the line of oh no, not p, this is going to be m dot, and this is going to be pwm. So this would be 100, and I think it was linear, so it was linear but not full. It was a bit like, I mean, probably like so. And the others will go with blue. So one would be basically ideal, so it is the same height, so basically H is 0, so it doesn't have to pump. It basically carries the fuel from 0 PWM, I mean till a point, probably it saturates, but let's go with this. And then with different PWMs it doesn't, or different heights, it doesn't start there, because it needs a given amount of PWM so that it or no, yeah, so not like that, like this. And maybe the thing is flatter, so that it doesn't have as high as and fuel output. A higher PWM is needed, probably something like this if it is linear. If it is not, then it would look something like yoink, like bending downwards. But I assume this is what it should look like in practice. So straightforward modeling, alright? Derived combustion proxy. Unitless proxy. Q total air. This is kilogram per sec, and this is kilogram per sec as well. Alright. Or P proxy, yes, which is phi, which is fuel derived by QR total plus APS. I don't know what APS is. S. Layer sequencer. State machine. Idle, purge, initialize, ignite, stabilize, run, shutdown, fault. Gain plus bias block for Q. For delta P square multiplied by coefficient something. Input blocks. These are constant blocks, constant step. New blank model. No, how the fuck does this work? View markings, no, I don't want that. Image, annotation, sample time. Debug, modeling. Insert subsystem. How the fuck do I start this? Modal Explorer. So long that I have not done this. What is this? No, finally. Modal Explorer, I don't care about this. Finally, we have something. What is this? Subsystem. Can I edit this? What was the odding? Oh yes. Oh, I see. Okay, subsystem, simu. Can I delete this? Yes. I think it was. this is constant. C M const odd. I think this was it. Constant or constant. So add 3 input blocks. Constant dash step. Maybe input blocks. Const dash step. Is there any? Constant. I'm thinking that input blocks. Maybe this is, maybe I should just use this input like this. Let's try it out. What is this? Port number. Gain plus bias. Output function call. Inherit port dimensions. Minimum. I think we want this. Hello? Implement your QR main using gain plus bias. Is there a thing called gain? Yes, I remember that there is a gain. Is there bias? Bias? Yes, gain and bias. Gain and bias. Alright. Implement with your fitted A and B. Okay, in. Fuck you, move. So this is, we call this blower. Gain, which is going to be, I suppose, A. Oh, I see. Okay. So the linear Q versus PWM. Where the fuck is this? I think this is it. Gain, I think bias is this. So this, the gain should be called, I think, PWM, and we should call this can't take it out of the equation because I think this is the gain. Okay, and this is the bias, which is actually not plus but minus. Minus 52746. Fine. U plus BIOS, add BIOS input. Add BIOS to input. U plus BIOS equals Y. This is, yeah, we call this, yeah, I mean, PWM gain, whatever gain, this is BIOS. Okay. Port number 1. Put a scope on QR main and sweep PWM. Put a scope on main. Oh. Okay, so we call this not auto rotate, we need a scope. We call this the what do we call this? Q. Let's go with Q. We call this, yes, Q scope. Is there anything happening? Maybe these should be connected or something. Compiling, let's see. Blue add. Yeah, nothing is happening because there is no what do you call this? No input signal. So AB, the blower should be like a port number. Like, oh, maximum 1 0 or not 100 or it's fine. Maybe I will need to adjust or use a yes, because this doesn't work now. We'll use a constant. Delete this, take this to here, and we do not use 1. Const value, let's say 50. No, is this 0.50 or 50? 100%. No, I think 0.50. Markers enabled to highlight data. Maybe 50. Ready, but here it is. 10. What is this? Maybe it was good before, so maybe 0.5. 0.5. Run it. This is supposed to be or maybe the 50 was right. Oh yeah, maybe the 50 was right, because the yes, because the 50% should supply us something along the line of, why the fuck can't we see it? 8.4, I would say. So 50% should be 8.4. Pretty spot on. Pretty spot on. Alright, so it works. Just need to refine it a bit. Okay, because we don't have a function. I don't know why. I don't know how you can make that. Because this is just the... I will save it. So yeah, that works with like input. Yes, maybe we will change it to different settings so that we let's say we put it to 60. 10.6, let's say. Why the fuck doesn't it show it? Markers enabled to highlight data. 10.6, let's say. Where is the plot? 60%, 10.6. Yes, looks accurate. This is 11. Alright. 70%. Let's go with 40. That's about 6.8. 40. Yeah, 6.8. It's about 7. Okay, great, it works. Okay, this works, great. So what do we do? Add placeholders, blocks for Q atom and M fuel, K fuel dash K atom placeholder. Oh, this is like a constant. Q atom placeholder blocks. I will need to ask him about this. Constant. Use the gain and bias. Okay. PWM fuel. To see response. There is a thing called step. Step. I think this is the step function. Signal builder. Import. Call a bluff from Matlab scripts without changing the downstream mapping. Better for test sweeps. Step blocks. Step for PWM blower. Proxy quantities. Change. Fuel PWM. Add fuel. Do a linear placeholder identical in structure for the blower. Alright. This is the gain, this is the bias. Alright. Okay. Yoink. Yoink. Alright. Fuck off. Can I move the whole thing? Hooray. Alright. Move the whole fucker. Okay. And then we are going to Control C, Control V. Fuck you. Guess what? Atom steps. Delete these. Boom, boom, boom. Boom, boom, boom. Boom, 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 boom. And we are fine. Alright. We'll need to adjust these later on. And I'll set them to 0. 0. Bias 0. Bias 0. Okay. Alright, blah blah blah. Call this PWM fuel. And this is KF. I mean, we can keep it gain. B gain. This is P gain. And this is A gain. Okay. Quashed. KF bias block with BF. Oh, we should change those as well. Great. Okay, bias. And this is going to be B bias. Maybe we should change it to BF. Maybe we should change it to BF. BB. Bias. Fuel or pump. Let's go with fuel. And let's call it pump. This is BP, and this is going to be BA. This is going to be gain, we call it KA, is going to be KP, and this is going to be KB. Okay. Fine. Fuel. QB. Fuel. And we have a QA. Can I move this? Whatever. Whatever. Fuck you. Okay. What values to use? Set KF. KF1 just a proxy. BF0. In percent 0 to 100 KF. So I'm fuel proxy is 0 to 1. KF 0 F. Blower bias. Oh, this is bias. Okay. Bias flow fuel to set it to 0. This to KF1. And this is going to be M proxy. Gain should be not this much, 001. Okay. Oh, this doesn't require. Okay. Steps. What are steps? Constant step. Aha. So Fi atom doesn't have a bias. Yeah, it doesn't have a bias. It just only has the steps, which is a constant, and has a K gain, so it doesn't have a bias. Alright. Okay. Delete this. Fuck this. Not QA proxy. Whatever. Fine. I will hop down, get myself a piece of bread or something so that my stomach gets a bit chilly. Like coffee always fucks it up. So I'm going to come back. Let's see. Let's go with this. Huh? So, const steps, phi atom, alright. Create atom set for 1 now. Use a sombra. Fine. Create Q total. Const, we will need a const, a sum, a divide, Q total. So what do we need? Q total, M proxy, fuel proxy, plus epsilon. Epsilon, yep. Epsh is this, I think. Fuck you. No. Epsilon. Alright. We need to what do we do? M fuel. So take the fuel. Yes, M fuel proxy and epsilon and sum it up. And then use the divide to divide the Q total with this shit. Where the fuck do we put this? Here in the middle. Mm, uh, how do we do this? Touch, put number of inputs we want only to divide. No attributes. Okay. Um, what is this? Yes. U times yes. Two things times one thing. Mm. Mm-hmm. If I put this here and put this here, fuck off. Oh, I see. But then how the fuck do we do this? So can we do dot point this? Invalid, what is this? Matrix? Oh yeah, fuck you. What? Yes. Only one input port for multiplication purposes. Single class. What is this? Element wise, yes. Alright, fuck you, come on. This is so annoying. Yes? Times or divide for each input port. Mm-hmm. No. Fuck you. Very annoying. Divide block. I mean, these are easy. Transport. I don't want function. Maybe this. shit. Mm-hmm. Mm-hmm. Divide. Great. So basically, we do not need this. The other one. Times that and divide. I think this should work. Alright. What do we do now? Yes, we have this. Alright, divide. Okay, this gives us a reach lean proxy signal you can use for logic and safety. Yes. K atom gain to similar magnitude to Q. I have no fucking clue how much it. Ratio R. Mix ratio. Picking K atom so it's not useless. Zero zero one. Alright. It was 2 or 3 0. Didn't save. I think it was 2 zeros. Yes. Fuck off. Huh? Alright. Internet is not doing us any. Yeah. Okay. Okay. Ah, fuck off. Bitch. Use this. KA. Whoop. Okay. By the way, you can use this. Does it? Oink. Okay. Whatever. 8. I think we want a bit less or more. Let's go with the bigger one. Freeze the fuel pump, fuel proxy scaling KP right now. KP pump. Set KP to 001. Okay. Epsilon is 1000. Alright. Odd saturation blocks. Command input. Command input, okay. compare block. Compare to relational operator. I think this is it. Yeah. So main type, yes, data type, boolean. This is the output, this is the in. How does the fuck this work? Applies the selected rational operator to the inputs and outputs the result. The top or left input corresponds to the first operand. So this. So the top is PWM blower. Greater than PM min air. Put it here. PW, this is going to be blower min or PW min air EG25. Is smaller than the oopsie doopsie. Odd breakpoint, this is it. Force pump to 0. If true, pump pass pump PWM output. We should put a switch block, that's it. Yes, switch block. So switch block should switch the How does this work? Pass through input 1 when input 2 is satisfies the selected criterion. Input 2. threshold. Oh. Yes, so to satisfy the selected criterion, otherwise pass through 3 input. Pass through input 1. Control port. Greater than. We don't even need this. Oh. So first when the first 25 comes in here, and when it is okay, so basically when this is true, this is criterion, so basically we compare this, and if this is true, oh, we can set the threshold to 25. Okay, threshold greater than 25, and then we don't even need this. We don't even need this. We can take this line and fuck off, put him into the second one, and then let the first one, yes, this basically lets the signal through if the, so this lets the first signal through. This lets the first signal through, and this lets this. This looks pretty shit, not gonna lie. Yeah, maybe the pump should be above this. And maybe the pump should be the first thing, not the blower. Then it would go up, and this would come. Oh, but it would be drag the pump up as well. Yes, take this to here. Take this to here. Ah, looks terrible, man. God damn it. I think we can add another plus here. I think we can add another plus here. Nope. Yes. Yeah, it doesn't look too nice, honestly. Fuck off. how does this look like? Not good. So yeah, you should use another of this. Poop, and put the second here, and then don't use this maybe. It looks trash still, but this is a bit better than the one it was. Fuck you, come on. Fine. Okay. Mix ratio, okay, save. Oh, hello. I am creating this Matlab model for my burner, or the future burner, because now it is partially done. The what is this? The control logic, I would say control and safety logic is going to be this. I'm learning Matlab, so, or the Simulink actually. I honestly don't know much about it. I have went through the on-ramp and I know about the blocks, so to speak, but have never done this before, so I'm a newbie. I am learning as I go through the whole thing. If you have any questions, you can state them in the chat section or whatever this is called. I think I will be able to see it. I have like 5 seconds of delay or something like that. So there is a pump, a blower, and the atomizer. Wish I had better pictures. I will need to take pictures for the whole thing. Yeah. So I am putting together this block. Basically, you have the blower, which supplies most, probably like 70-80% of the air to the burner, and that there is the pump that carries the fuel to the burner, and then there is the atomizer, which is basically just a compressor air screw that allows compress the into the oil gun, which breaks up the fuel into fine droplets, and will maybe paint it a bit. So just going to do it by hand. It's not going to be nice. So we have the outer shell, we have the cone here, we have an inner line, or it's shorter because it ends just before the cone, and this comes out at the end, so this is welded here. We connect the fuel to this. Here the fuel goes in, m point fuel or m dot fuel. We have the air, the atomizer air coming in here from the compressor, which is Q dot A, and we have a other thing here that is here and here. I forgot the labeling. So we have a external shell that is kind of similar to the thing. There is a tube in here which is there to premix the fuel, as well as that there is a line which carries propane butane so that we can ignite the whole thing, and on the other side there is a ignition plug or spark plug that ignites the whole thing. It's going to be very rough, sorry. So basically here we have the the ignition plug, which is, I think, pointing towards away from the thing, and basically we carry the fuel into the carry the fuel from the pump to the oil gun, as I call it. That there is also atomizer air, which is the high pressure compressor air, which comes in here, and that there is like a very small ring called annulus, which it looks kind of like this. So that there is the outer diameter, and there is this inner diameter, probably bigger. Great that it doesn't work. Whatever, it looks kind of like this from the front view, and the inner thing is inner tube is basically a bit inner, so it has like a 2 millimeters inset, so that the air can move past it. And basically here, where there is a very little gap, but gap is here about 1 maybe 2 millimeters thick. Basically the air can speed up so much, it expands to atmospheric pressure, as well as like it has a very low amount of surface area compared to the amount of volumetric flow that it has. It speeds up very fast speeds, and basically this the fuel comes in, and it shears the high velocity of the air, basically shears up the fuel here, and it sprays it into a cone. And this is like an air helped or air guided this is a external mixing type injector. The internal mixing would be basically that you have the air combined in the chamber as well, or in the inner pipe, and the pressure would create the cone, the spray cone, whatever. So the spray cone is created here, but first when we ignite the thing, we put in some propane butane on this line. So the propane butane is ignited with the ignition plug, and then when we have like a stable flame, then we start basically we use the atomizer or blower air. Where is it? Oh, I didn't yeah, there is also the blower here, which I didn't draw. This is the blower air, Q dot blower. The blower provides us the 70% or the majority of the air through this port, and basically with the blower I'm probably going to drill holes in here. I don't have them, so that basically we will be able to mix the blower, and it creates like a nice swirl, so that the gas have a good mixing. So we'll add that, but we don't have it now. We'll add a ring of holes, whatever. So first, propane butane in with the gas, well, with the compressed air for now, because we don't have the blower hose. We would need to add the hose there, so that we can do with the blower. So compressed air with the propane butane ignition, we have a stable flame here, nice propane butane flame. Then when we have that, we can slowly increase the fuel, which is diesel or veggie oil or use motor oil, whatever. And as we pump in the fuel, we will basically not be able to ignite it first, because we don't have enough volumetric flow from the compressor yet. We'll need to step it up, so nice and slowly. So first we start adding a bit of fuel. We have a flame until we have a flame, but we don't add so much that we basically quench the whole thing, and we basically just flame off. Basically we create like a flame off. So we add slowly the fuel, and we also ram the atomizer air, so that we have a nice mixture, as well as we start to slowly also increase the amount of blower air, because the problem probably will need to add the hose first. I will need to start with this type where I just talked about. So we start increasing fuel slowly, then simultaneously we start increasing the atomizer air, as well as with a bit of delay we also start to increase the amount of blower air, so that we create a nice mixture. As well as the problem is that if you overdo the air, then it basically blows out the flame, and then that's it. If you also add too much fuel, then that does the same thing at some point. If you also increase the volumetric flow of the compressor air, that also blows out the flame. So you need to be very finely tuning the whole thing, and I will need to make a test for that on how much I can push it one at a time and all that kind of stuff. So we'll need to, so to speak, mop the flame, so that we have like a useful fuel versus all this to air, as well as like the propane butane will be closed when we have a stable flame, as well as when we have like a flame off, which means that we don't have any flame, but we provide the fuel still in, we spray the fuel in, we'll immediately close the fuel and still run the blower and the atomizer air, so that we purge the whole thing out, so we don't create like a propane butane trap in it or anything like that can blow up. So yeah, this is the I will save this. So yeah, any questions? We'll now continue the thing, and I will keep my half eye on this. I don't know how I will need a second monitor so that I can look at the chats from time to time. So yeah, I'm just reading this thing because it's new for me. I don't know too much about Matlab simulating. I'm not gonna lie here. Yeah, I'm a master at this. I have no fucking clue. So basically, switch block, if through, pass, pump, PWM. So basically, this is kind of like safety, so that we add the purge that I was talking. So if there is not a minimum of 25% of blower PWM, which is basically just roughly speaking equal to blower output volumetric flow, so 25% of that, which is, I don't know, 4 liters or something like that per second. So if that there is not amount of that, then we basically will not allow the fuel pump to provide any fuel, because then we would not be having the quench or the purge. So yeah, also we'll later add a solenoid valve for the propane butane. I will now just use my hand and a manual thing that I will use basically to adjust and turn the needle valve, the adapter on it. So yeah, this is this switch that it's supposed to do this, and we have saturations, yes, mirrors, whatever. So the whole thing is done by an STM32. I don't know if you know about that. That basically is I had this what is this called, F44R. This is it. I usually look at this side. So I have this guy, this STM32, which is kind of like the Uno, just industrial version of it. It has basically a set of Uno capable pins here that they call the Uno headers or something like that, or Arduino headers. Yeah, Arduino headers. These basically are just as the Arduino, have the same pins here. So you basically, if you wanted to, you could actually put a Arduino here, just snap it on, just like on a shield, and you have an extra one layer on both sides, which is a additional line of they call it morpho headers, which are these. So basically, where is it? Oh, it's not here, but whatever, they call it morpho headers, which are these little male pins that are free, that these are an additional line or additional row, and this is basically just the mirror of the pins of the Arduino. So basically they are internally connected, so that you can basically have them parallel connected to the same pin if you have like a ground or you want something like that. Or actually, when you have a PWM here, you can use PWM, which is kind of like a fun fact. You can use one PWM output to control two things. One is the positive side, one is the negative side. When you put out PWM 0 for one, it gives another one, the PWM 1, which is if you put out a PWM of 30%, then if you connect it to the same thing, but on this pin you put out the PWM, or maybe you can't. I don't know if you can, but whatever. So the PWM, no, I don't think you can because it's the same pin. So reverse, I take that back. Yeah, you can't. But you can use both of them if you don't want to use male pins, just females onto these. So yeah, side quest ended. This is a very good thing, very useful board. It's so much better than the Arduinos and the ESPs because they are capable of basically you can go into the code and adjust hertz or like clock speed and all this kind of stuff, so it's very good. You can manually choose out which pin you want, which function. There is so much more than in just Arduino. Arduino is just very stupid compared to this. So yeah, coming back to this. So microstepping, we have the microstepping, which is the just the freshly made thing. I'll show, not this. Just yesterday made the, and yeah, before yesterday I have made the stepper screw, which is this, which where the fuck, yeah, here is the controlling board, and basically I don't know, I will find myself the yeah, I have done the wiring yesterday or the day before yesterday, and I need to find, yeah, here it is. So it was on the thumbnail, but whatever. This is like a stepper that controls a needle valve that allows the atomizer air into the oil gun, and basically that's fully automated, and we can control it by the STM32 with a stepper motor driven thing, and it also has like a end switch, kind of like a 3D printer, so we can home it and we can know which step or which position it is actually on. So yeah, going back here. So it's automatically the real machine. Mechanical range. Later you will set aux pos to the actual travel from homing. For now 12k is okay as a placeholder range. Edits, yes, BB, KB, yeah, I have done this, KA, yes, KP, okay, KB, okay, epsilon, alright, a saturation block on each input, on the blower minimum before fuel switch. Okay, if you tell me typical blower operating range, yeah, it was about 40 to 75%, I think. Guess the typical pump PWM for stable flame. I think it will be something like blower is normal range, normal op range, operational range is about 30 to 75%, which is kind of stable. Pump will be about let's say 8 to 10%, maybe lower, so about 8% to, I'd say 16%, 16% ish. We'll know what the overhead is. What the overhead not what, how exactly the overhead H changes the amount of fuel that it carries. Alright, also I have done the gains and costs, also added the switch, set an internal limit to 25. Saturation blocks as well. To make a picture of this. At least I will be able to use this as like a thumbnail or some shit. So which one is this? I don't like the Simulink that this is. Why is this so white? Isn't there like a option or some shit? This looks disgusting. About Simulink. I need to save this. It looks kind of shit. This white mode is disgusting. Honestly, I love this dark mode. About Simulink, great. We will just do this. Put the picture here before we forget. Okay. Send the message, it will freeze out anyways. So if you have any questions, you can ask them at any time. I am looking at the chat box from time to time. Sorry if I don't respond immediately. And fuck you, Matlab. Close this shit. Scaling. Middle input control signal. Oh, but I did this. One data input. Pump PWM. Why this fucking shit does this always? Where are we? So yeah, other data input 0 constant. One data input pump PWM. Yes, pump PWM, the middle one is control signal blower PWM. Okay, it's 0 constant. Okay, we don't care about that. Set criteria, yes, that is done. Should be U2 control blower, U1 through path, pump PWM. So yeah, yes, force path. Yeah, I think that is done. Yeah, of course, but I think this is done. Well, because the pump date is 1, 2, 3. So 2 is the control. Okay, then it is good. Choose KP, so fuel proxy. Normal pump range. 0. KP to 0. BP. Oh, BP to 0. Okay. This is 001. 001. There is this pump. This is 0, this is 0. Okay, this is exactly what we want. Good. Okay. Second contribution is secondary but noticeable. Set Ka to whatever. Okay, and then take it down. Take the Ka down to this. Whatever. Maybe should use like something like 4 or something. Whatever, this will be fine. Yes, your blower mapping constants. This, yes, this is done. Consider adding saturation after QB to prevent negative flow after QB. Okay. QB. Okay, so we should set the whole thing. Fuck. Can I? Can't. So then we delete this and we inverse it. Ctrl C, Ctrl V. Okay, we do this and we put a saturation block here. Yes, put this here. Okay. Okay. Good. Set this to QB sat should be 0 infinity. Output minimum 0. This should be infinite. Finite, or then not in here. Signal main upper limit. Then if fuck you. Maybe we should not do this and set this to yes. I think this will do. Linear if it can go slightly negative, great. Okay. Mix ratio correctly. Yes, this is done. 160 unitless proxy, that's okay as a proxy. Plots logic, you can scale it. Add a gain after mix. So we add a gain. Call it what we call it, mix ratio scaled mix. I will call it KR because the ratio is the R. Scope, great. Mix ratio OO is the same. Yes, it's the same. Okay, good. KR then becomes 03 to 1.6, easier to use. Next thing to add we're doing now. Safe region, clamp for fuel based on mix ratio, proxy FR. FR is the air to fuel ratio. This safe region is basically so that we run in a not just safe for the mechanically, so it doesn't overheat the burner, but also it does work, so it's like a operation region as well. And when the two overlap, then that is the safe region, I would call. Mix ratio is smaller than Armin. Set pump PWM to 0. Alright, so we need another compare switch gate. Armin. Start with the conservative Armin 2030 in your current scaling. Oh, mix ratio. So we use a compare block, or this. We can use this as well. This switch. So switching. We put the switch to here. So we basically put the controlled line into here. We put the output block here, and we take the second. This looks terrible. A bit better. So yes, we take the control thing from mix ratio. Somehow should be able to pull this down. Looks shit still. Whatever. So mix ratio should be a bit above. Yes. And we should adjust this to so that U2 this is greater than 25. I mean that's still good. 20, 30. Okay. Save. Greater than threshold. So this needs to be greater than this 25. That's great already. Okay. That gates pump. Another switch that gates pump PWM. Oh. If mix ratio set pump to 0. Oh, not blower. I fucked up. Okay, then we can we use multiple switch? Not the blower, because this is the pump, right? Yes, so I have yeah, we'll go back. Not the pump, we need the switch, but we need the blower, or the pump again, sorry. So I was thinking that, do we audit serial? Or so think, if we have the pump and it is basically enabling this shit to go through, then basically we have a mix ratio, something mix ratio, and then we will be able to take the mix ratio and lead it back to the switch. But if we do not have any pump thing going out, then yeah, probably we should look at the switch. But if we look at the switch as well, then it will never start, right? Because if we do not have a this is very annoying. I will have to ask this, because if we I will tell. So if we have the switch here, another switch here, so basically I take this and take the whole thing out, draw this out a bit, and maybe delete this, and draw this out. Okay. I don't know why it does pull on this. No, I'm gonna delete this. Wanna pull this out. So if I take this and take this and draw this here, yes, and I maybe here, I add another block here, no, yes, this works, but not this. This goes to here, and this should be a bit slid backwards here. So basically, if I take this sample from here and have the same thing, so 25, the problem becomes that the if I run the pump at a given thing, PWM, and basically the blower works, then the signal goes through. But because the thing just now started, the mix ratio will be basically, or if I send out the command, wait, I'm just thinking, if I send out the command, then he doesn't know that the mix ratio is not, you know, done physically, but the parameters are set so that there will be a bit of delay between when the physically it happens and when we command the data. When we command the data, we already set all this shit up so it computes, and we already have a blower and an atomization, so we already have a mixing ratio. And if the mixing ratio is greater than the 25, then it goes through, and it basically allows the whole thing to go through. Alright, but if we do not go above the 25, because I don't know, we are low, we're just starting, then this pump will not work. So yeah, we'll need some tuning with the data so that with the lowest amount of values we will be still able to run the pump, because this can be a problem. We'll have to add a note or something. Can I add it? Canvas color. Oh. Black. Yeah, let's just let that go. Gray. Oh, this looks better. Okay, so the interesting thing is, yeah, I will have to adjust it. Are you still here? Alright. So we'll need to tune this won't be able to start the blow the initial we won't be able to do the initial startup of the burner, so we'll need to edit it. Alright, so transfer function. Okay, so where were we? Yes, what to do next when you resume tomorrow? Do immediate model upgrades, replace K8 times steps with 1D lookup table, steps phi atom, placeholders, the guest points, add simple actuator dynamics, first order transfer functions on blower and pump commands, T tau, which is that time, 02, 05 seconds, so steps aren't instantaneous. that will make the model behave closer to reality and prepare you for state machine sequencing. Yes, feedback. Current limit is set to 25 ratio. Do we need the compare functions or blocks if the switch has already built in what is this? Oh fuck. Alright. So it's getting noon, 11:49. So I will start to prep to have a lunch, and then come back and do some. Yeah, I think I will do still some modeling, or maybe start taking out the shit. So I don't have my phone here to show the setup, but I have already prepped everything so that I can transport them out. We need to start up the compressor outside, so that because that there is like -6 or 5 degrees outside, we need to check if the compressor even runs or some shit, because the water can be frozen into the compressor tank. Hope it does not or did not. But I suppose if there is like a 2-3 bars of pressure in the compressor, then it would lower the freezing point. Yeah. Maybe increase. We'll have to check. So does higher pressure change? I mean, it does, but where? The freezing point of water. It does, but the question is that does it increase or decrease? Yes, high pressure lowers the freezing point. Yeah, that's what I expected. So basically, higher the pressure, the lower the temperature is Fahrenheit. Oh my god. 100 megapascal, we don't want that. Boiling point at 1 atmosphere. What is this? 1 pascal, 100 pascal. Critical point. Freezing point. So this is 0 C at 0 C at what? 1 atmosphere, which is 100 kilopascal. So if we increase this to 10 bars, this is fucking shit. Let's go 3 bars, because that's 2 bar gauge. 3 bars, slightly above standard pressure, freezing point will be just below 0, so it's not that much different. lower temperature. I mean, it doesn't really, so yeah, it can still freeze into the fucker. Doesn't really change that much. Steam or like evaporation, and not evaporation, what do you call it, boiling point does significantly change with pressure. You do not need a separate compare block. Yes, yes, yes. Switch versus compare. Yes, yes. Pass input 1 as input 3. So for no fuel allowed. Oh, maybe we will have to adjust and put some zeros here. Constant 0. We'll put this here, and we'll put this here. So basically we'll put a big fat 0 into the pump if we don't. And I hope that this will work. Yeah. Save it, and then we want to Boolean signal. And or explicit with relay, readability debugging. Switch on is fine. Not block start up. Correct. During ignition, mix ratio may be bad because fuel is low, high, transient. You should not have fuel mix ratio smaller than limit. Active during startup. Proper approach state dependent logic. Make a mode signal. Is that a mode block? What do you call it? Model. Echo mode. No. This is not it. Make a mode. Start up. Only enforce blower air. Manual switch temporary. Easiest. In Simulink, easiest is a manual switch temporary or a constant mode on. Okay. Manual switch. But there is a manual switch. Manual switch. How does this work? Oh, hello. Okay, so we will remove him for now. Or we could. Oh, but we can't, can we? We would need this with a compare and the manual switch. So if we switch this manually, then the compare would automatically be off, right? We'd connect this. Yeah, probably would connect this to this, and we would connect this to this. It would be basically open, so it would be a 0 here, and the other line would connect to the how the fuck do we do this? Connect to 0, the other line would connect to, I mean we can do this, yes. So basically we take this out, we delete this, we put this here, yes, we take the sample and we take the 0 to here, and we take this back, and mix ratio, we don't really need this for now. We can switch between these two fuckers, so basically now it's on, now it's off. Alright, this is not too bad. Okay, so this is start, we will call this startup switch, start up switch. Alright, pull it a bit back. Alright, looks alright. Manual switch, pump, PMD, PMW, CMD, blower gate, few command logic. If mode run the mix ratio gate as bypass. Yes, this would be just the later on. So basically you would need another switch. Either this, or you would need another switch. Basically take a switch here that would be basically taking pump PWM, take it to this, and maybe that's more fancy. Make this then. So basically we have this switch which takes the pump PWM into a consideration. Yes, this is absolutely ugly as fuck. Yo. Or oh no, I forgot. So yeah, this is here, pump, which is this. We take the pump, so we take the pump and fuck off. Okay, take the pump reading, and can we rotate this? No, maybe. Format, mask, properties, whatever, don't care. So basically we allow this, which is there is another fucking switch. We allow this switch to work, which if this PWM, pump PWM, is greater than, let's say 8%, let's go 8%, I don't know. If it is greater than 8%, then this feedback from here will be allowed. If not, then it will not. Mix ratio. So mix ratio can be, or is it fuck? Oh no. So this, if this is okay, then we take the signal we don't, I think this would do this maybe, or we do this but not with the that logic, we not greater than, we no way that there is no, that there is just only greater. Is this like a joke? That there is no pass through input 3. What? Pass through input 1 when pass through. Okay, so basically if we take this, then it passes through input 3. Otherwise, egyébként. So basically it would not let it go if we, so this only is true if the second is okay. So if it is greater than 8% in terms of pump PWM, then the fuel, then this limit switch will allow this through. But that is not what we want. We want either smaller or wait a minute. So otherwise let the 3 through. So basically if we take this here and we are greater than 8%, then we allow this 8% shit in here, and if we have this through as well, then we take this and we put it here, pset. Can this, come on man, why doesn't this work, for fuck's sake? Delete this, take this, boom. Okay, otherwise take this. So this is what? Threshold 25%. Yes. So basically if the pump is, the blower is 25, yes, then we let this through. If not, then we cancel this out. We should put a this gating is so fucking shit. Oh my god. Yeah, I would need the compare blocks. These switches are shit. These switches are shit. Not good. Compare. So if this is greater than this, then what is this? Boolean, output Boolean, fixed data, inherit. So basically selected rational operator. So input corresponds to the first operand. I will need to fucking look through this. I will go back to the manual switch before I completely gutter the fucking thing, and we will continue from here. First, it is good for now, we will come back later. God damn it. So actually I will take a break now for I think like 1 hour, and then I will come back and then continue this so that we will be able to run the Matlab thing so that it is like a viable so that it is like so to speak viable and it is working, and when it is that, then I will go and do the things. What I will need to do is I will need to rate 20, still small, 36. So I will need to do a few things, which is mop the pump, the air screw, fuck you, screw, mop the air screw, also mop the pump, and before that I will need to prep compressor and take out shit, and also hook it up, cause the I need to make like a manometer that is able to measure the so have a what I didn't talk about the thing, so that we have a pipe that has an internal smaller diameter, which is an orifice plate, and we take samples from both sides and basically we route it to different two different things. We have a U manometer, which is a device that is shaped like a U. It is a basic pipe, and it has it's basically a water level. It has 2 cups on it that can be opened or closed to the atmosphere with little plugs on the top. So basically, when we take the readings to the top and there is water inside, and basically we put the pump or we put the Q flow here. Q, it's ugly as shit. So Q pump or not pump, blower, oh fuck me, I can't, blower or compressor, let's call it air screw, yeah, let's go with compressor, so blower or compressor, the amount of air comes here, because it cannot go straight through, it has some restriction, the flow slows down and the velocity converts into static pressure, and basically that will be higher, this pressure 1 will be higher than pressure 2. So pressure 1 is greater than pressure 2, and what that means is that we have a greater force than here if we basically these are like closed to this, and so basically we have a greater pressure here than we have here, and that means that we here compress the gas in the thing, or no, sorry, the basically the pressure is equal to a greater force here. That means the water level is going to be pushed down compared to this, and that will give us a difference height, which is delta H, and the delta H is proportional to volumetric flow. Fuck you. So proportional to volumetric flow. I mean, it is proportional to delta P, and delta P is proportional to volumetric flow, but we can say that delta H is proportional to volumetric flow. I've already measured or like calculated out empirically the my device, and it is if you build in the future something similar, then you will have a different device, because mine is 57 millimeters in diameter. The inner diameter is, I think, 33 or 32 or 34, I can't remember now, but I will write 32. So this is basically, mine is 2.36 times delta H, or yeah, delta H. So this is in millimeters, so water height. So if I had a 30 millimeters, so 3 and 0 of water height difference, then we would put the 30 millimeters here. We take a square root of 30 times 2.36, and we get a good old 13 liters worth of volumetric flow per second. So yeah, that is how I do that. But I will need to, back to the point, I will need to set up the manometer and all that kind of stuff, so that it is straight and nicely parallel, so that I will be able to read the values. Because now it will be needed to be manual, because I don't have a high enough rated pressure sensor that can read the compressor's gauge pressure, which is 2 bars gauge, but that is actually like 3 bars of atmospheric pressure, because it is this gauge is basically compared to atmospheric. So 1 is basically 0 on the gauge is atmospheric, and so on. So you get the point that 2 is actually 3 bars worth of atmospheric pressure, or like it is with 1 bar shifted upwards. So I don't have a high enough pressure sensor that can withstand that, which is I do have a 200 kilopascal, which is basically 2 bars gauge, which is basically what we would need. But if the compressor turns on, it can damage the pressure sensor, because the compressor wants to push the air up, and the reductor is basically taking it down. But if there is like swings momentarily, transients, that can actually damage this sensor, so I don't want to use it. I want to measure the flow first with this manometer, and actually if it is dropping down to smaller, so it is not that significant as like 2 bars of diff pressure, then I will use my sensor. Just for now I don't want to, I just want to test it out if it is going to be, or how big it is going to be in water height difference. So yeah, this is for now. I will mute myself, and I will come back at, let's say, 13:15. So let's put this here and edit this to 15. So right. So if you want, then you can come back then, and then until then I will take my little break and yeah, show the Matlab thing. Alright, so see you then. I will mute myself then. Till then. I'm back. So we should hide this and let the screen take over. I think this music is copyrighted, so I will not. What was it? Oh, the switching. Yeah. Mm. Dun, 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 dun. Mm, 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 mm. Mm, 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 mm. Mm, 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 mm. Let's see what this is. So yeah, manual start up switch. I think her sequence is just the automated version of the. It outputs mode, startup, run, shutdown, commands, set points, blow RPW and pump it on atom steps as a function of time and conditions. State flow. Oh, I will have to download the fucking get more apps. Hello? This Matlab app is slow as shit. Or it doesn't fucking. This does trigger it, but the other one doesn't. Ah, come on. Get more apps. Fuck this, come on. No, it froze out. Great. No, finally. The state flow was the name. State flow. Exactly. State flow. This is what we want. Dun, 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 dun. Install. Dun, 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 dun. Dun, 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 dun. Dun, dun, dun. This shit takes forever. No, anyway. Died, but it's fine. Can't even close it very well. Matlab is not it, bro. Just not it. Alright. When it will start to, I don't know what it does need to preparing for, when preparing to install add-on. I don't know what it does need to prepare for. There is nothing in this. Maybe it just asks some server bullshit down, or I don't know what it does, but this is pretty annoying that it takes this long. Take a few seconds. This may take a few seconds. Yeah, I suppose that's the case. After this, I will have to make little boxes here. Hey. Control C, Control V, hello. Great. Oh, finally. Okay, okay, blah blah. Accept the Matlab agreement, please don't sell my kidneys. Alright. Install. It will close this the application now. Right, great. Then I will come back with a coffee till then, and then we will continue with the work. We need to wait always. No state flow. Automatically do blower on. We need to take apart the whole thing to add the hose into the inner core pipe so that the blower will be able to feed the thing. Because now we can only ignite with the atomizer. Ignite, blower on. Coffee is hot. Blower on. Clock. Block clock. So where is it? Oh, no way that it closed itself. Oh my god. What's up? What works? Good old lab. Simulink. Simulink. Busy. Blower on, fuel off. Other clock. This gives simulation time in seconds. Create phase signals with compare block. Compare to constant. Oh my god, please work, for the love of fucking god, start. No, finally. Alright. Hooray. It's a bit above 170. Yeah, 71, 171. Okay. Time. The fuck is this? Clock, not time. Clock. Cock. Alright, we need a compared to constant. Yes, this is it. Compared to const. Alright, a clock and compared to const. Alright. Create phase signals with compare blocks. Oh. We need 3 of these. Whatever, don't trigger shit. Add block state flow chart, then we don't need it. State flow chart. Alright. Create states. Purge ignite ramp run. started. I think I will do this state flow. Then I will get my shit together and go out and start prepping for the test. Alright, let's see what this is. Blower CMD, pump CMD, atom CMD for this phase is purge, ignite, ramp, run. Step 1. Chart, state flow. State flow, yes, chart. Drag chart into the model. Symbols plane. What do we need? View. Symbols plane. Symbols. Great. There's a fucking shit. What the fuck is this? Alright. Simulink function. No, because I think this is the symbols. Maybe this. Create these output data items. Output. Great. Igen?
Most le kéne pucolnunk a többi napelemet is. Mert ha odaadom a botot neked, fordítva, akkor megtartod, még följövök, azt átveszem azt valahogy a többi napelemet is, majd innen nem tudom, hogy le lehet megizélni.
Nem tudsz felmászni a garázs tetejére? Potyognak valami jegyek ide. Ezt becsukom. Wait a minute. Books. Oh, oh, the state flow is the. Ah, I have learned about this. Mm-hmm. 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 So we will call this time. How the fuck does this work? Create these output data items. Type double symbols play. Ay. Mm-hmm. parameter data. So basically we create output data items, these, um, come on, no, oh, just laggy. Alright, so we have, these are, I suppose, the outputs. Can I bunch them? Oopsie, what's this? Hello? What are these? They are going to be the states. States, let's say. Truth table. State box. Ho ho. State flow chart. Drag chart into the model. Double click on the chart to open it. In system chart, system panel, symbol panel, symbols plane. Oh, fuck. Symbols plane. I found it. Yes. Output data items, scope output. Create data, message, symbols, chart. Create data, input data, these are outputs. Output data, type, not data, it will be blower cmd. The pitch. There is this parameter data. Okay, so parameters. So pump cmd. Fuck you. Pump cmd and atom cmd. Okay, these are all outputs. All right. Create these parameters. Parameter data, 1, 2, 3, 4, 5. This is actually 6. If I call, yes, this is 6. So this should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, 6, 7, 8, 9, 10, 11, 12, 13, 14. Alright, these are, oh yes, fuck. Whatever. Parameter. Very interesting. Maybe I could have fucking copy-seed them. Probably would have been so much better. And faster. Whatever. So they are looking nice. Purge value. Hello? What the fuck? Scope, data items, scope. What's up with this? Size, same parameter. Scope, yes, type double. Type, shut the fuck up. Double. Size, what is size? What's size? What is other ones? Tunable info. Document link. Hello? Alright, so we will take these and then delete these. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, 12, 13, 14. Alright, T-purge, let's rename them. T-ignite. T-ramp. Blower purge. Blower ignite. Blower ramp. transition. I have seen that. Event message. No. Default transition. Boop. Oink. Okay. Ramp target. Where the fuck can't I click in this? Part 3. single click the parameter name tpurge.
Tényleg pokol meleg van, kérem?
És most nincs is olyan meleg.
Nincs.
Nincs. Ez még egész jó. Tegnap sokkal melegebb volt este.
Jaj, nyisd ki egy kicsit ablakot, ezt a tetőablakot, azt akkor leolvad legalább a napelem. Csak hülyéskedek, 23 fok van. Az Ildiéknél az teljesen jó, nem?
Na, fáznak.
Ott már fázik? Van pézséd? Lent elfogyott minden.
Ott van. Három óra? Remek. Be kell indítani a kompresszort, meg kell nézni, hogy működik-e.
Be van fagyva minden film.
Kiolvad.
Most ébredsz föl ilyenkor, 3 órakor ébredsz föl.
De eddig dolgoztam.
Azzal mi lett az a órával?
Nem tudom, szerintem lehervad benne velem. No, I can't see. Symbol spin table. Yes. Symbols plane. Properties. Double. Tunable. What is size? Yes, symbols plane. Yes. Column headers. Yes. Type type, yes. Right click on the column header row, enable initial. Value display format.
So state flow is a part of Simulink where you can basically do logic control. You can have very complicated logics for control of something or reacting to something. And yes, you can do that with simple ifs, simple functions. But remember, the main goal of Simulink is what? Is pictorial presentation. So you can see what you're doing instead of just looking at a bunch of code. You can see the diagrams, you can see what leads to what and so on, and you can understand it better and hopefully debug it better. So the goal of state flow is that. So state flow is kind of a pictorial presentation of the system logic, and depending on where the system is, in what state it is, in what situation it is, what kind of decisions to make, what kind of actions to take. Okay, and as we'll see, it's very good. It's like a block diagram system with wires and states, and you see transition between the states. And it's very easy to see, very easy to debug and understand. So it's really good for, as I said, logic control for systems that are event-based, right? So if some event happens, you need to do something, okay? For systems that have to react in real time or during some operations, so it gives you all of it. It's a really powerful part of Simulink, and I'm gonna talk about this in a few videos. So I cannot cover it in one video. So this video, you can consider it like state flow intro or basics of state flow, right? Or video 1, and then hopefully I add at least 2 more videos to talk about more advanced topics in state flow. So how do you make a state flow? So if you go to library, right, and first let's say make a new file. Now I'm going to show you what I have here for you today, but if you create a new blank model, right, so in here, create a blank model like this, and you go to the library, you can use regular Simulink blocks, and also if you go down here, you see that you have what? You have state flow. And under state flow, there are 4 major blocks. There is a chart, there is a sequence viewer, truth table, and state transition table. And what we're going to work with in this video is simply chart.
Chart.
You can use a chart, which involves basically states and the transition between the states, and you can go inside the chart. Once you go inside the chart, now you have a bunch of tools on this left hand side, as you can see, and these tools can give you a bunch of important things, like for instance, this is the most important one, probably the state, right? So you can drag a state, and I'll show you how to add the state name, how to add basically actions for it and so on, right? So this is the
great. Is it? Oh. Which is this? Ignite. During. Alright. Oh. Come on. Hey. Is this a joke? Yes. Hey, what is this? Okay. At the state action. Okay. Oopsie. No. Oy. I think this was totally unnecessary. John. Jó, már ki van itt?
Tessék?
Ki van itt? Itt a bácsi?
Nem jön olyan bácsi.
Onnan tudod.
Beszéltem magára.
Te nem? Mi van vele?
Akkor jött volna, hogyha kell neki utolsó, de megoldottam.
Aha. Mit tudsz? Water. Porrop. Milyen fogázol? Fogázoltál? Most be van gyökölve?
Nem, annyira kimostam a 10 évvel ezelőtt, hogy belefér még egy adag.
Ja, amikor kell
Nem bírtam kigyökölni olyan rendesen. rendesen, tudod, nagyon kemény, ezért nem viszi úgy.
Már lehet állni?
Amennyire.
Nagy kaszter. Húzd meg a csomesz. Mennyi idő múlva kell majd kenegetni, vagy sikálni a izével? A szivacskával.
Már megyek is rá, megcsinálom ezt a falat.
És nem dörzsöl nagyon ki belőle az izé?
Hát próbálom majd. Ha nem, akkor még egyszer átkenem, mert van még anyag.
De azt gondolom már csak holnap.
Nem, hát ezt nem.
Egyből lehet.
Persze. Hát a...
Mennyi idő még meghúzod a sar? Fugázó anyag az lassan fogy. Kapcsolom itt a villany.
Nem, majd kifugázom, és akkor holnap még kikenem szilóval a tálca tödét, és akkor holnap után lehet rakni a kasznit föl.
Rossz hírem van. Ez a te géped, ez megint akarja telepíteni a Windows 11-et. Valamiért. Hallod, apa?
És le tudod állítani?
Nem,
Nem tudod lebeszélni róla?
nem, nincs olyan opció. Next van, vagy nincs semmi. Hogyha kiixeled, akkor újraindul és megint behozza ezt a fasságot. Már megint nem tudom, mitől akarja ez. Mi a izé? Miért nem tudta felrakni a Misi a Alright. No, it's unused symbol. I just can't read. Ah. Press enter. Single click and press enter. It doesn't work.
És mi nem a te gépeddel baszkodsz?
Ez az én gépem. Azzal nem tudok semmit csinálni. Mert
És mikor jött elő ez a probléma?
tegnap még nem volt, vagy nem is tudom, tegnap nem kapcsoltam be, szerintem tegnap előtt vagy előtte. Szerintem izékor használtam szombaton talán utoljára, akkor még semmi baj nem volt. Tegnap talán nem használtam, és ma meg már nem akar. Nem akarja. Double click directly.
Nyisd ki az ablakot, mert már levegőt nem kapok.
Fölveszem a pulcsomat, még jobban betegszek. Képzeld el, a víznek a fagyás hőmérséklete nem változik meg a nyomással. Csak nagyon picit. Egy picit nem megy tőle. De nem sokkal, 0 fok alá. Fél fokkal.
És ez nekem mély jó.
Hát azért, mert azt hittem, hogy azért jobban lemegy, mert ugye a forráspont az tök sokkal elváltozik a nyomástól. De úgy néz ki, hogy a fagyáspont az kurvára nem. Single click doesn't work. Double click, no, it doesn't work. Click somewhere else. Value cell, press F2, type the number. Click on the value cell. You can't click on the value cell. Data. Great. Mm-hmm. Na, becsukhatom a ajtót, nem a...
Aha.
Lefagy a lábam. Model Explorer. Model Workspace. Model Name Top. Model Workspace. Column name 3434. This is 6 plus 8, 14. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11. Step 4. Make the chart. Use those variables. Back to the state flow chart. Hooray. Yes. Yes. Update. Diagram. Back to Simulink. Go back to Simulink. Press Ctrl D. Do-do-do-do. Hopefully it doesn't fail. Please work, please work. Oh, please work for the love of God. Compiling. View 1 warning, great. Okay, no problem. Don't mind it. Alright. Matlab command window. Great. Okay, I don't want to do this, so I will stop. I am exhausted as fuck from this shit. So I think that's it for today. From here, I will go outside and set up the things for the later tests. I don't know if I will come back today. I'm pretty exhausted from this shit fest, honestly. We'll set up the compressor, we'll test it. So anybody who was here, thank you for joining in. Otherwise, do the hard work, especially when you don't feel like it. Mwah. Mace Ringer is out. Maybe coming back later with the tests, who knows.